Now we'll try to find out the range in case of this interchangeable functions. So finding range. Question number 1. Find the range of modulus of sin x plus modulus of cos x. Now you can see graphically, this is the graph of modulus of sin x and this is the graph of modulus of cos x. So you can note down the rule. I will explain it once I will be teaching this maximum minimum topic. At this time you can note this down. Case of symmetry. If at end points you are getting the maxima, this implies that at point of symmetry you will be getting minima. Okay. If so what is the meaning of this? You'll see it. I can't explain it at this moment, but once I will be teaching this maximum minimum concept, this will be pretty much clear. Okay? So now you can see that this whole function will be start repeating after this one, this period of pi by 2. So you can see these graphs are symmetrical about pi by 4. Okay, this plus this. So this graph is symmetrical about pi by 4. You can consider up to this portion. You can consider this. Okay. So at endpoints at 0 or pi by 2, what is the value of this function? 1. If this is 0, 0 plus cos 0 is 1. At pi by 2, this is 1. This is 0, 1. So at pi by 4, this is the point of symmetry. We will get this as 1 by root 2 plus 1 by root 2, and this comes out to be root 2. So this is the minimum value and this is the maximum value. So I can draw the graph of mod sin plus mod cos x on the basis of this only. Its period is pi by 2. So in one interval, if you draw the graph, you can generalize this. At 0, the pi by 2 this value is equal to 1. Now at pi by 4, this value is equal to root 2. So this value is root 2. Its graph is somewhat like this. So this graph will start repeating like this. Its graph is like this. Okay? This is pretty much clear now. I will take some more example. So if at endpoints we are getting minima, this part. So at midpoint or at the point of symmetry you are getting maxima. Now, and minded that this concept can be applied only if this is a perfect case of symmetry or interchangeable case. I'll take another example. How I can say that this function is symmetrical about x equal to pi by 4? In one cycle you can see this whole function is symmetrical about x equal to pi by 4. How come I can say like that? Yes, you have noted. So you can see I have already told you once I was teaching even odd concept. If f of x is equal to f of a minus x, so the function is symmetrical about what? X is equal to a by 2. You equate these two. So 2x equal to a, so this function is symmetrical about a by 2. The same thing you can do here also. What you can do, you can check it out. Suppose this is f of x. Is f of pi by 2 minus x equal to this? Definitely, because f of pi by 2 minus x is modulus of cos x plus modulus of sin x. So this function is symmetrical about x equal to pi by 4. Okay. Now I'll take another example here. Second one. Find the range of sine to the power 4x plus cos to the power 4x. Now you can take this as any power you can take, but these two should be shared. Now this is again a case of symmetry. At 0, you can see this function is, again you can draw the graph of sine to the power 4x. This is like this, between 0 to pi by 2, and cos to the power 4x is like this, between 0 to pi by 2. In between you are having a point pi by 4. So its period is pi by 2. Okay. At 0 or pi by 2, this value is again equal to 1. At pi by 4, this value will be 1 by root 2 to the power 4 plus 1 by root 2 to the power 4. So 2 times 1 by 4. So this is equal to 1 by 2. So at point of symmetry you are getting minima, and at endpoints you are getting maxima. So its graph is again very easy to draw. You can draw this one like this. You can see this is 0, this is pi by 2. You can check out the calculation also. Okay. So at 0 this value was 1, at pi by 2 this value was 1, at pi by 4 this value is 1 by 2. So its graph has to be like this. Okay, it will start repeating like this. Is it fine? Okay. This is pretty much easy. Now it's okay. Again the same thing is applied here. This function is symmetrical about x equal to pi by 4. So this is again a case of symmetry. I'll take one more example. This is a very important approach. Without doing anything you can get the range based on some fact. Now find the range of a square sine square x plus b square cos square x plus under root of a square cos square x plus b square sine square x. Okay. So how you can find the range of this one? So again you can see what is the period of this function. What is the period of this function? If you will do like this, by rule it should be pi. This period is pi, so the period should be pi. But again, even powers are there. What is f of x plus pi by 2? This becomes a square cos square x. This becomes b square sine square x. So this changes into this one, and this changes into this one. So what I have told you that either modulus function is there or even powers are there of trigonometrical functions, then you can apply this one. So this is equal to f of x. So this is having a period of pi by 2. At 0 or pi by 2, what is the value? This value is, this is 0, this becomes b, this becomes a, so this is b plus a. At pi by 4, what is the value? Under root of a square plus b square by 2, and this is 2 times. You can check it out, this is very easy. So under root of 2 into a square plus b square. So the range of this function is, this is the, definitely this is more than this one. So range of this function is from b plus a to under root of 2 times a square plus, you can verify this, this is the range of the function. Okay. So this is again very easy. If you will do it some other way, it will take at least 5 minutes by using maximum minima. But this is short technique here, this is very important. And this is not the method only to apply in this trigonometrical one. Wherever you are having a case of symmetry, you can find the range. Okay. Now, you should rub this thing. You have to find the range of, I think this is over now. Should rub this. Now find the range of, question is find the range of I think this is fourth one, 1 by sine to the power 100x plus cos to the power 100x. Okay. So what is the period of this function? You can see the period of this function, again this is interchangeable case. So the period is pi by 2 here. So at 0 or pi by 2, the value of this function, let me first try to find out the range of this one. This function is 1, and at pi by 4 this value is 2 times 1 by root 2 to the power 100, and this is 1 by 2 to the power 49. This is 2 to the power 50, so 2 cancels, so 1 by 2 to the power 49. So what is the range of 1 by this one? So the range of this complete function is equal to 1 to 2 to the power 49. You have to reverse this because both numbers are positive. This is from 1 by 2 to the power 49 to 1. You have to take reciprocal of this, so it becomes 1 to 2 to the power 49. So this is the range of this function. How are we getting this? We are not applying any other concept than this case of symmetry. Okay? This is pretty easy now. Is it fine? Good. So now, I'll stop here for a moment. We'll take a break. You can revise this.